Hello, I'm Mr. X, Mentor of Mathematics, and this lesson is trig 097. Angles, circumference, rays, degrees, minutes, seconds. You need to be comfortable with these concepts before you take anything called trig 101. Oh, I'm just messing around with rays. That'd be Ray Charles. Ray Charles. Absolutely. Love the late Ray Charles. How could you not? Okay, enough messing around with that. Let's talk about rays. Sure. If these rays are actually at the same, start at the same point, then they make an angle. And we usually look at the smaller angle. In other words, we're generally interested in the angle between the rays the short way instead of going around the long way. Sometimes we're interested in an angle bigger than 180 degrees. It does happen. This angle would be more than 180, and this angle would be less than 180. How big an angle do you think that is? What do you think, 130, 140? Well, we can punch up Geometer's Sketchpad and get some quick measurements. You need to be able to guess the size of an angle. Well, how big of an angle do you think this is? Well, let's measure it. It labels it for us and says this angle is not quite 120 degrees. I thought it was more like 130. It's kind of hard to tell how big an angle is when the angle itself is sort of at an angle. You'll come to know what I mean by that. Would you say this angle is more or less than 90 degrees? Looks like it's just a little bit more to me. Well, let's see what Geometer's Sketchpad has for us. It says angle ABC is 92 degrees. Yeah, it's slightly bigger than 90. Let's do one more. Now, what would you guess the measure of angle ABC? Well, it's not quite 180. If it were a straight line, straight across, it'd be 180. So it's probably 170, 175. I don't know, 170. Let's see what it says here. There we go. It says it's just more than 170. About 170 and 1/6. Anyway, you want to be able to get an idea of how big angles are. All right, before I leave this, I tried to make something straight. Remember, it's still an angle. Did I get it perfectly straight? Well, let's see. No, I didn't. Pretty close. If those were perfectly aligned, what we call collinear, then the measure of angle ABC would be 180 degrees. So yeah, you want to be able to guesstimate the size of angles. What makes it easier is when one of the rays is horizontal. Then we could say, oh, that's pretty close to a 90-degree angle. Sure. Or we could say this is pretty close to a 45-degree angle. Sure, it makes it easier to guesstimate when one of the rays is horizontal. You'll come to appreciate that. Now, this business of degrees, minutes, and seconds, it's pretty hard for me to draw this with the equipment I have, but I'm going to give it a go just very quickly here, at least an introductory remark or two. We're going to say this is a 1-degree angle right here. The rays that are a little more bolded, they're separated by 1 degree of angle. It's actually drawn a little bigger than 1 degree because I can't draw as small as I'd like to draw. But let's assume that that's a 1-degree angle, the separation of these two rays. If we separated this 1-degree angle into 60 smaller angles, then each of those angles would be a minute. 1/60th of 1 degree is a minute. So it's a very, very, very small angle. Now try to stay with me now. I can't draw it. I don't have the equipment to do it. But if we did the same process, if we zeroed in on this 1 minute angle and could divide that into 60 smaller angles, divide that into 60 equal parts, Now we're talking very, very, very small angles. Each of those would be a second. As the language works with time, 60 seconds make a minute, and 60 minutes make an hour. Works the same for degrees. 60 seconds make a minute, and 60 minutes make 1 degree. Finally, let's talk about circumference. One diameter is the same as 2 radii. So if this is the center of our circle, free-handed, and we had a radius that went out this way, the radius of a circle is the distance from the center to a point on the circle. And we had another radius that went out this way. If the angle formed by those 2 radii was 180 degrees, in other words, if they were perfectly straight, then we'd have a diameter. The diameter goes all the way across the circle through the center. I'll just point out quickly that if you have a line all the way across the circle, but it does not go through the center, like this purple line or line segment, we call that a chord. In order for it to be a diameter, it has to go through the center. So 1 diameter is the same as 2 radii, or if you like, 1 radius is half a diameter. Yeah, radii is just a plural of radius. So 1 radius is half a diameter. Now, how do we get circumference? That's the distance all the way around the circle. You start at a point on the circle and go all the way around the circle. What's this distance? How far is it around the circle? Well, we call that circumference. So we're going to let this capital C be circumference. Circumference is pi times diameter, or 2 times pi times the radius. If you like, we can put multiplication dots in there, if you're not used to this terminology yet. 2 times pi times r, or pi times the diameter. We don't usually write the multiplication dots, though. After a while, we just put these symbols and numbers together. 2 times pi times r. Of course, this is the value of pi. This is a closer value of pi, but it's still approximate. I happen to learn pi to 40 digits. I learned it by learning 5 phone numbers. Five phone numbers after 3.14159. This is all you really need to know. 3.14159 or 3.1416. But since the circumference is pi times diameter, let's divide this side by d and divide this side by d. What happens when we do that? Divide pi d by d, we get pi. Divide circumference by d, and this is what we have. That's pi. It's the ratio of circumference to diameter. If we have an exact circumference, which is kind of hard to do with human measurement, and an exact diameter, again, hard to do with human measurement, but if we had those exact numbers, we'd have exactly pi. Pi is a constant. Pi never changes. And the only way that we can express it exactly is to just rely on this symbol, this small Greek letter pi. Okay, have we messed around enough with that?